Alright, today we are going to be using the 5-number summary to draw the box plot and then able to answer questions. And then you're also going to be using the medians and the interquartile range to compare two groups. So you're going to have different sets of data, actually 3 different sets of data, and compare and contrast what you see and notice about each one, looking for similarities and differences. But first, we need to review how to draw a box. So, 10 6th grade students were asked how much they sleep in hours that they usually get on school night. Here's the 5-number summary of their responses, and we are going to go ahead and draw out their box plot. They've already done the putting the numbers in order and figuring out each of those values. Now that you have them, how do you draw them? What's the first thing you want to start with? Yeah, okay, let's start us off.
Like the second quartile.
Second quartile, so that's also representing my median. Good. So my median is at 7.5. So I'm going to go ahead and draw one line at 7.5. Use that. What else? What's my next step? Tegan.
Maximum is 9.
Maximum is 9. So what can I do on 9 right now? I can draw my end cap, my whisker. Okay, I can use that. Yep. What else can I do, Trevin?
Get the first quartile.
Yeah, first quartile is going to land where?
7.
7. So I'm going to go ahead and draw a line right here at 7, and I can actually make the box and connect it to quartile 2. Yes, Kelsey?
Third quartile is 8.
Third quartile is 8. So I'm going to draw a line right there at the 8, and I can actually go ahead and connect that box.
And then you can do the whisker over.
And then Riker?
The minimum is 5.
Okay, so my minimum is 5, which is going to go right there. And since that's my min, and I know where quartile 1 is, I can go ahead and connect that. And finally connect it to my other whisker, my maximum value. And there is our beautiful box plot. And it is kind of a mini one. It looks really small. I almost want to push it out to zoom in to see this a little bit better. All right. Marley, question.
Are we ever going to get to the point where we have more sets of more than 5 things that we do quality, inequality 5 or something? Not just minimum and maximum.
So
other stuff or the whiskers for lengths or something.
no, this is it. This is as far as you're going to go. The only other way that I've seen this drawn is with more like a point to connect it instead of a line.
I didn't know if we were going to do something else where we had
That's what we did the
actions or
first
something.
day.
So I always used to do dots, but now I likes to draw ends, and I kind of think they do that to remind us of our ends of our boxes. Because we kind of use that as my min and this one as my max, and it kind of replicates that little inside boxes, lines. Yeah, it just doesn't close it. Okay, number 2 says, what questions can be answered by looking at this? So now let's ask some questions and then find the answers. Kayla.
You could probably find out how many hours and get specifically because there's nobody goes over 9 hours, nobody goes under 5.
So a good question could be, what is a typical amount of sleep these 6th graders get? What would you say is a good representation of a typical 6th grader's night? What value would you use? Lauren?
7.5.
7.5. What made you choose 7.5? Because it's the median. Do we agree? Yeah. What measurement don't we get from this box plot? We don't know exact times that they went to bed. We also don't know exactly how long they slept. We know where their data points fell, but I don't know if there was only one person that slept 5 hours and everybody else was landing at 7. and everybody else was landing right on 8, and maybe there was only one person that slept 9. We don't know from this. We do know that at least half of our 10 sixth grade students, so what would be half of 10? 5. At least 5 people landed between 7 and 8. That could have been right at 7, that could have been right at 7.5, that could have been right at 8. But I know 5 of my values landed in there. Do you remember when we made our human box plot yesterday? We had some that were quartile 1, and I made them stand on top of the line. Why did I make them stand on top of the line? What do you think? To keep the line straight, yeah.
Or either like to show where they were in the like
Yes, to show where they were in the quartiles. So let's think about this. If I have 10 students, how many are falling in each quartile?
No, it'd be
2.5.
Oh.
So, right? 2.5 are landing here. 2.5 are landing here. 2.5 are landing here, and 2.5 are landing here. And the question should be, how do you have half a student? And what did we do? I made you split it because half of that point was in quartile 1, while the other half was considered in quartile 2. Remember when we were doing it, you were like, oh, it's the second 11. And I was like, okay, let's see how that works. So, knowing that 50% of my data falls within the box, that's a good representation of our sample. What else can we answer? Yeah.
You can find the interquartile range.
Good. Interquartile range. What is my interquartile range? The distance between quartile 3, and I'm going to subtract quartile 1. And in this box plot information, 8 minus 7 gives me an interquartile range of 1. Woo! That's small. That means I've really narrowed data right there. What else can I find?
The minimum and maximum?
Min and max. What's my min? What's my max?
Min 5,
Good. Max. And then using those numbers, what else can I find?
Range.
The range. Home on the range. I can find the range. We used to call it spread. Now we know the word for it. It's called range. Max minus min. Range of 4. Isn't it crazy how much information you can get from just that 5-number summary?
Yeah.
So much fun. So today, you are going to have not 1, not 2, but 3 different data sets. Yeah.
when we're like next year or like if we still do this, will we get bigger numbers to do it with, or like
You could have bigger numbers, right? Right now, we're dealing with really realistic situations. But could there be a time, like Coach Katie mentioned yesterday, wasn't it in here where someone was like, yes, it was you. She was like, shout out to that girl, she's thinking. When you were like, why would we just, like, we could just visualize all of this data. Like, we were only messing with 10 numbers. We were only messing with like 20 pieces of data. And her response was, what about when you have 4,000 numbers?
yeah.
And it was like, oh, I don't think you want to list out 4,000 data points and be like, tick, 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 tick to find your median. There's going to be a calculation that's going to help you. Okay? Yeah.
Maybe you just do 4,000 divided by 2.
Yes. And you would go all the way to your 2,000 number and be like, that's my middle.
And that'd be 2,000.
Right. And then how would do you want to keep going? How would you find the middle of the first half? How would you?
2,000 divided by 2.
Right. And so your first quartile range would land at 1,000. Oh, you guys could do big numbers. We're not. But you could. Because you're going to do the same process. You are. All right. We're flying paper airplanes today. Ooh. And each of these designs kind of happens in different ways. So it says they launch each plane several times and record the distance of each flight. One really nice thing they did for you. is put them in order already, so that process
And they
is
made
done.
us a table.
You are actually going to copy this table onto your boards because that's how you check to make sure like we all good, all right. Once I see that everybody has their table done, the next thing is to draw them on a number line. You're gonna make the box plots on here because on here it's really, really small. We have fat markers. Fat markers don't do well with tiny boxes. Okay.
Make us bigger boxes.
We need bigger boxes, and so your dear old teachers know how to screenshot things and blow them up for you.
You're so kind. Blow up my baby.
You're lucky for my first group, because they were the ones that were like, this is too small. I'm like, you're right, just a second. You guys always get the best lesson.
We do, and then we have
Yeah,
to
you're troubleshooting. All right, we're going by colors.
We're fine.
What are we doing, bud?
We're just putting on the grill.
We're cooking on the grill right now. Right here. Putting your chair and put your foot
Pink and yellow, you have to. I'm orange. Yes.
Listen.
Pink and yellow, go, go, go. Thank you, thank you, sweeties. Nice job, nice job. Blue and yellow are winning the race. Yep. We're gonna use up the, nice job, Pink. You're in third place.
Do we have marker yet?
Forward.
Chat, we don't have
Oh, yeah. What? I didn't feel it. Nice job, and black. Nice job. You got them all? Perfect. Drawing the box. Nice job getting that chart up on the board. Then go ahead and you don't have to reunite all your numbers.
Hang on.
I would just use them on the paper.
That good? Put 2 lines. 1, 2, 3, 4, 5, 6. Put 2 lines. She said we have to sit at the same spot we did.
No, not like that, not that way.
I'm gonna move this back for you. While you guys are standing there, you want to go ahead and sign this one for me? Thank you. They're erasable pens. In case you forget your signature. I had some people. Oh, good question. Mr. Steiner, you presented in here for Pi Day. Mr. Steininger. Harper Steininger's dad. He was the one that was in here.
Wait, where did he go? Why?
We're saying thank you.
Why are they sending him? Because
He presented in here on Pi Day.
yeah.
You're just saying thank you.
Oh, I thought something happened to him.
No. It's just the idea that they might have had to take off work to come in.
Did we do it for the other classes, some other people that presented too?
Yeah, everybody. Yeah.
I was wondering because I haven't signed anything for anybody else, so I was like, you should do that.
Yesterday, Mrs. Lingle had a card for Harvest Call.
Oh yeah. What's that bar? IQ. That looks like an A. Whip. We should do one for Ryder. Does that look like an A? No. Yes, it does. No. Okay. Andre. His minimum is 25. So minimum 25. And his max is 30. Okay, we got that. It's Q3. Q. Oh no, it's like medium. So 27 plus 28. So like after that, it's like really That looks like a 5. I don't know, that was like 32 and a half. No. 32 and a half? No. I don't know. Oh, no, 2.
What does it look like?
4.
Oh,
1.
you went right style. You were like,
Divided on that. Do that, divided on that.
wait,
How many times can 2 go into 15? 7 times. 7 times 2. 14. More. That's 2, 4, 6, 8, 10, 12, 14, 17. 7 of it.
In the air fryer or?
17.
air fryer all the way too.
And point 0, and then time, there, and then 27.5. What was that? Yeah, that's it. 27. I get to go. And shoot. Yeah, keep it.
Okay, right from my son. My dad's 42, you are going to be, or the box
So the IQR, so then Q1.
Yo, 57 divided
Oh,
by
wait,
2 is
27. 27. Yeah. No, me!
divided by 2. What's So inner quartile range.
Q1. 27 is Q1, Tegan.
How do I get my inner quartile range?
Oh my god. This is why you feel like
That's 28.
give me my book.
Nice job. So basically you did that for this one and you got 2.
No, you gotta do the
The math. Just
We're wrong anyways, bro. You got in the middle.
Quartile 3 for mine is 29.
28, 28 is 29. Okay, what's 9 plus 8 minus 10?
Yeah.
15, yeah. 57.
Yes, it is. Oh, you ready? Looks good. Wait, yeah. Make sure each person has a chance to draw one of those boxes, okay? One of the box plots. So you guys can
Okay, 2.
use it on this.
Is that 17?
Just draw like
You're 17 goes in 8 times. I think.
that way.
Yeah.
Make sure everybody gets a chance to
4,
draw a box.
6, 8, 10, 12, 14, 16, yeah. And then, wrap that down, 10. And then it goes in 5 times. And then,
You mean natural? He was natural. Good, so 28 and a half is gonna be quartile 3. Good, and then what would be your range?
this. Oh, no.
Oh yeah, sorry, inner quartile range, you're right. So,
Oh.
because range, when I said range, you said min and max, which you're right. And then I reread it and saw that it was inner quartile range, and then it uses totally different numbers. So then we're looking at this one and subtracting this one.
Oh, okay. 1.5. Yeah.
Wait, what are we adding? 18?
1.5.
My home is 13.
Not gonna go in. Minimum 20. 20. 20. The maximum 32. Cooking with Kaya. Cooking with Kaya.
This is correct.
Cooking with Nyla. Cooking with Nyla.
So 8 was my,
What's a good one so far?
this one, this one, so remember, that one was gonna be here, so it's gonna be okay, so this is gonna be a little bit easier, 21. No, don't, this one's correct, because remember, high school, we're kind of 28 is here, one here, one here, one here, on this one.
My God, Connor. Look at Connor's handwriting. It's not that bad.
And this shows.
So, I'm gonna have you.
21. Oh, that's cool handwriting.
Those done?
Is that 27?
Yeah. Alright, flip it to the back, leave that information. Flip it to the back, you're gonna do like a same and different. Okay, so on the back side, keep all of this information. You guys are same and different on the back side. Alright, I'm gonna have you guys.
29.
Oh, there you go. Okay, wow. You guys were whipping on that one. Alright, interquartile range.
From 8. Let's do 8.
Okay, so now instead of doing Noah, I want you just to draw Andre's box plot and Lynn's, just to get some practice using those two, okay? So once you get those, we'll discuss.
Draw 3 box plots.
So just put Andre and Lynn, okay? That's so cat road.
Quartile. That's 20 something. 27. That needs to be 25. I think. I don't know. I don't know how to do it. I'm not good at drawing box plots. I'm just good at Wait, is it outside recess?
You actually don't need the calculators. You're turning down. Okay, so the mid is.
You didn't ask for any. You're not that good, bro. You should have asked. It's not going to be that fun that's not taking your money. I don't care. You should have asked. That's why I give it up.
Okay.
So I gave like a lot to me last night. Yeah, but it's just the amount of money. I don't even care. It's not mine. How much do you have? Oh, spring break. Oh yes, spring break. Or Sunday or something like that. Oh yeah, spring break sometime. All the days.
Okay, we're gonna go ahead and put a cap on your marker, but bring your box plots here to compare. Bring your box plots here.
We didn't finish.
It's okay, bring what you got.
Okay. It's a square.
We have square. Alright, so, looking at Andre, we are seeing that his median is 28. We noticed that his range is from interquartile range is 27 to 29. And then my whiskers, my minimum is at 25 and my max is at 30. He's got a very narrow-ish space here, right? Compared to if you drew 2 box plots, you now see that, wow, it's a lot wider, right? We have a larger max, but even a lower minimum, okay? So did anybody get to the comparing and contrasting of Andre and Lynn? Okay, and it's okay, but you're gonna be able to listen to this conversation, okay? So we're gonna catch you up. What's the same about Andre and Lynn? And you can still chime in even if you didn't get to this point just by looking at their box plots. What's the same, Michaela?
I said that, I said they are the same because they have the same median. They're different because they're quartile 1.
All right, same median, but their quartile 1 is different. Excellent. Any other similarities? Yeah.
Wait, no, I have a different.
Okay, the difference?
Their epsilon is different.
Interquartile range. Look at that. Interquartile range is a 2 for Andre, and Lynn has an 8. And then you could have also find similarities and differences between Lynn and Noah. What was cool about Lynn and Noah, and even though you didn't get to draw this out completely, Lynn and Noah both have the same interquartile range. But notice where they're located. What does it mean that Lynn and Noah have an interquartile of 8, but Andre's interquartile is only 2? What does that say about their airplanes?
The same airplane?
They're way different.
Oh.
Okay, so if I want a more consistent airplane, who am I going to ask to make it? Why would I pick Andre to make a very consistent airplane? What about his dot plot shows that he makes a very consistent airplane? Yeah.
Well, he has pretty much all of his range isn't as big as the rest.
Perfect. So I know that I have a half of a chance, 50%, of the airplanes are going to land inside here. And even then, the other quarter and the other quarter are very close to that data set. Lynn and Noah, they have a lot of variability in their flights, okay? They have a lot of different numbers, and they're very large in their interquartile range. They're not very consistent.
Noah's
Yeah, Marley, what else?
I noticed something different is that Noah, like the maximum is at 25, and then Andre, like the minimum is at 25.
Oh, good, they line up, wow.
But
So his farthest flight was Andre's lowest flight, which is kind of interesting. Yeah.
His maximum, or first, Andre's maximum and minimum were smaller than all the rest because they were.
Andre's max and min were smaller than the rest. Well, Lynn had at least one flight that flew farther, but it could have only been one. They might not have been very often. All right.
So we got Andre